Okay, guys. Hello. We are going to start with the first lecture of statistics for engineers. The title is Introduction to Statistics and then Probability Theory. So basically, that's what we are going to do. We are going to revisit statistics and then talk about some of the concepts of probability. Okay. So in simple terms, statistics, as he explained in the slides, has to do with the collection of data, right? Organizing or analyzing data. So you analyze your data and then you interpret the data. So those are the major things that have to do with statistics. You are obtaining data, analyzing, and then interpreting. But then there are other things that can come to play too, such as planning and organizing. Okay, so when you talk about sampling, you are trying to get some part of a population. Right? So when we talk of a population, we are talking about the total number of items or individuals that are available to you for your experiment. Okay, so sampling will have to do with taking some portion of the population for simple reasons because the population is not fully available for you to use. You want to do a study in Ghana, you can't do the study on all Ghanaians. Or, for instance, you have to reduce cost or for other factors. So, yeah, so you just always need a sample. And then with a random sample, you are trying to get just randomly some members in the population. So, so whatever you pick, right? So you can have your sample space. So yeah, and you can have your sample point. So these are all the groups of members that are available, right? And then these are a specific. So let's say you have a Venn diagram, right? So every point in the or every circle in the Venn diagram specifically will be a sample point. And then when you consider the sample space, it will be the space of possible all the possible groups that you can be working with. Okay. Now what are experiments? So when you have a sample, you can run the experiment. An experiment can be anything, as tossing a die, um, tossing a coin, sorry, or rolling a dice or anything. So all of those are experiments. And we have random experiments, which are examples of experiments. Basically, they have uncertain outcomes. You're not sure what will come. But then definitely you get something, but you're not sure exactly what you get. Like tossing a coin. You're not sure what you get, whether heads or tail. So after tossing or after the experiment, you get your event. Yeah, so the event is the result of an experiment, and it can be anything. Have random events, and we have certain and impossible events. Certain events are events that you know that after doing this experiment, definitely this will happen. So, for instance, when you toss a coin, you know that you are either going to get a heads or a tail. Now, with impossible event, let's say so things that cannot just happen. So you can't toss a coin and expect to get six, right? From a dice. It's not just possible. So if you toss a coin, you get results for a coin. So that's just what impossible events mean. We have unions and intersections. I know most of you, almost everyone knows this, so I'll just hit a little on it. Yeah, so unions will simply have to do with combining terms, right, in maybe groups or sample spaces or sample points, yes. And then intersections would be the common things in the spaces you are talking about. Okay. Okay. And then yes, so that's just a brief overview of what we're doing in probabilities and in the statistics, the general explanation. That's just it. And then when you come to, I think there are some terms he also mentioned in his slides. He mentioned things like a finite samples. Um, so if a sample is finite, then you have a fixed number, right? You have a definite number. It can either be countable. So okay, we have countable infinite too. There's also possibilities. We have non-countable finite events, discrete samples. Yeah. So all of those are terms, just the same idea. Mm. Okay. Okay. So let's just briefly go to the next thing and talk about probability, since these are all familiar terms. So the concept of probability. When we talk about probability, we are considering that you have, um, let's say for an experiment, you have outcomes that are not certain. So outcomes are uncertain. And then what you are trying to do, you are trying to evaluate the chances of something happening. In other words, you are trying to estimate uncertainty. Okay, yeah. You are trying to estimate uncertainty. Okay, and then we have axioms of probability. Um, just like we have laws, theories, and so on. We have axioms too. So when we talk about axioms of probability, or just axioms in general, axioms are fundamental truths. I mean, like truth. This one. Yeah. So axioms are fundamental truths in nature. You don't have to prove them. It's not necessary to prove them. For instance, um, okay, it's just like saying that. What's an example of an axiom in real life? Okay, maybe this is not a nice one, but then something like every human being would die. It's a fundamental truth. You don't need to prove it, right? Yeah. So that's an example of an axiom. So when we come to probability, there are majorly three axioms in probability. So let me just say axioms in probability. Three axioms. Now the first one is that probability is always between 0 and 1. So the chance that something can happen is always from 0% to 100%. Just the idea. You have another axiom that says that the probability of a certain event um, equals 1. I mean certain, like this one. So probability of a certain event equals 1. Yeah. And then you have another axiom that says that the probability, so if the probability of something happening depends on individual probabilities. So for instance, let's say probability of y um, depends on some other probabilities, like maybe y1, y2 to yn. So the total probability of y happening is simply the probability of the addition, right? Um, yeah, in that order, to probability of yn. Now this one would, so for instance, let's just pick a practical example. So in a class, right? So in a class, if you are going to graduate, now the probability that your class graduates, so probability that your class graduates is equal to the probability that each of you graduate, right? I hope this makes sense. Yeah. So it's just the, so that will be the sum. So you're just going to do summation of the probability that each of you graduate, and that gives you the total probability. So that's the general idea of the axioms of probability. We have other expressions in probabilities too. So if you take, we have something like probability of A union B. This would come in handy in one of the examples would look at. But then for now, this is just an introduction. Minus probability of the intersection. Right? I'm sure most of you are familiar with this, so I'll just leave it and we move on. When we get to it, I'll revisit it. Okay. And we have properties of. Okay, so let's just come back here. Now we have properties of probability. So I want to talk about the properties of probability. For instance, let's say we talk about complement. So probability that, for instance, the probability of someone buying something is 0.3, right? Then that essentially means that the probability of them not buying it is 0.7. So the probability of a complement is the probability, it's just 1 minus the probability of A. Yeah, so this is one property of, and then what I stated here is also another property. So the probability of the union is the probability of each minus the intersection. Yeah. And then we have, for instance, so if you have 3 events, so for something like this, let's say you have 3 events. So you have, say, probability of A union B union C. So that would be probability of A plus probability of B plus probability of C, right? Then from here, you start doing your subtractions. So you subtract the individual intersections. So you do probability of A intersection B minus probability of A intersection C minus probability of B intersection C. Right. Then from here, you now do your final addition. So probability of the general intersection, A intersection B intersection C. So that's just it. So this is one of the properties of probability as well. Okay. Now, with probability, the easiest one to tackle, right? So the easiest one to tackle are the independent events. So when we say independent events, events that simply the occurrence of one does not depend on the other, right? So we can pick example. So let me just put the general formula. So the probability of independent events where A and B are independent is their product. Yeah. Okay. So we can pick practical examples to talk about. So for instance, the probability that it will rain today, let's say it will rain today, equals 0.7, because it's been raining a lot nowadays. And then the probability that maybe Elon Musk could buy maybe a new company. So let's say Elon Musk buy a new company is a 0.45, right? Then if we want to calculate the probability that it will rain today in Ghana and Elon Musk buying a new company is their product. So we'll have 0.7 times 0.45. So yeah, so that's just it. Now let me pick a like smaller numbers so that we see what is really happening when you're talking about independent event. So let's say the probability of something happening, right, is 0.5. So let's say probability of A happening 0.5. Probability of B happening, let's say that too is 0.3, right? Now these are independent events. Now we realize that when you multiply these two, right, what do you get? You get 0. What? Something like 0. Okay, so you directly get 0.15. Quite straightforward. But then when you check what this number was 50%, right? So let's say this was 50%, and this was 30%, right? Now when you multiply them, you end up getting 15%. So which essentially tells you that the probability of independent events happening, what it does is that it simply reduces the probability that something happens. So it reduces it. So once they are independent, the probability that they would happen at the same time constantly reduces. And when you have more terms, imagine you have more terms, you keep multiplying and then the number keeps going down. Yes. So that's for independent events, right? So for independent events, just their product. And then if you have more terms, yeah, like I said, so if you have probability of A, comma B, comma C, and then all of them are independent, then you just say the product, and then product, right? Yeah. So that's just everything for this one. So independence events are relatively easier to solve. Now, where do we get an issue? We get an issue when we are talking about dependent events. So the occurrence of something depends on the other. In that case, you would really need to consider the effects of each closely, right? Yes. So let's go to the next thing. The next thing we'll be dealing with. Okay. So dependent events. So let's talk about dependent events. Okay. So for dependent events, we're trying to say that what happens in one affects what happens in the other, right? And then they have notations for writing it. So you can write probability of A. Now when you write this, right, you read it as probability of A given B, right? So A given B. So this means that B has happened already, and then A is yet to happen. But then now that we know that um, B has happened already, what will happen to A? Yes. Okay. Okay. So we have a some form of a general formula for it. Okay. Okay. So for something like this, we'll have probability of A intersection B all over probability of B. Right. Yeah. So this would mean that the intersection, so probability that A and B happen, all divided by the probability of B, will give us the probability that A will happen given that B has already occurred. So in this case, the probability of A would always be changing based on what is happening to B. Okay. So in the example he gave, in the slides he gave some example of some three friends who went to a restaurant, and then there are 10 types of sandwiches. You can always check that out. There are 10 types of sandwiches. So let's say 10 sandwiches. 10 sandwiches. And then each of the three friends have the same probability, like of picking, right? So there's equal probability of pick. Okay, so let's say they're equally likely to pick any order. Let me put it in that way. And you want to find the probability that each of you will pick something different, right? But then you are making the assumption that all of you are picking. So let's say if they are 10, right? The first person to pick, high probability that you pick something. That'll be 10 on 10. Now the next person to pick, that would simply be, so that would simply be 9 on 10, right? Because you'll be left with like 9, but then you're assuming that each of you is to probably pick at the same time. Then what happens? Then the other person will be like 8 on 10. Now this one is quite straightforward. It's not like the actual probability calculation, right? This is really straightforward. So when you have to solve this one, right? In actual mathematics terms, it will actually look like you have the probability of the first one. So let me call him A. And then when you are doing the second one, so you multiply, right? So that would be times probability of the second one happening. So B happening, given that A has happened already, right? So this one would mean that A is the one. So this guy has picked something. So what's the probability that you will pick something, given that he has picked something? And then the last person will be the probability that C will happen, given that let me say A intersection B has happened, or A and B has happened, right? So this is how it will look like, but from a rational point of view, it's simply the same thing. Yeah. So when you multiply these, you end up getting what he had in the slides to be 0.72. Yeah. But then we'll find other examples that would make it more interesting. Okay. So this is just a starter, right? So let's drop this for now. But then we'll do more of it in conditional probability, where you have to fully deal with dependent events, right? Events that depend on each other. That's what we do conditional probability. And then when we are doing Bayes theorem, we'll talk more about it too. So let's go more into some of the other things he had in the slides for lecture 1. Now he had Venn diagram questions. I believe those are straightforward. Yeah, and we'll solve them later on and then see if we can just post them around. So. And we have the third one. Can talk about statistical terms, quartiles, deciles. Those are quite straightforward, so I'll leave them. And percentiles. Okay. And we spoke about, yeah. So basically, that's everything for the lecture one. That's everything for lecture one. So let me just give a small recap what we tried to do. So in lecture one, this is what we're trying to do. We're trying to understand what statistics is, trying to understand what probability is. And we said statistics has to do with obtaining, analyzing, interpreting data. But then there are other things that come to it. But then those are the major three things that have to do with statistics. We spoke about sampling, experiments. No one asks you, most likely, no one asks you to define these things, but you should just know them so that you know how to go around with your questions. Yeah. And then we spoke about unions and intersections, and these are quite familiar faces. Yeah. And then we spoke about concepts of probability. We spoke about probability being so we're talking about outcomes that are uncertain, and then we're trying to calculate the chances, or basically the uncertainty. And we spoke about the axioms of probability, the three main axioms of probability. So that's this, and that. Okay. And we spoke about what independent events are and how to calculate independent events. And then we also spoke about if you have a number of independent events. Okay, so these are general formulas for properties of probability. So let's leave this one. So we spoke about independent events, how to calculate them, and then we came to dependent events. We just read down the general formula, but then we'll revisit this one when we're talking about conditional probability. Okay, so for the meantime, that will just be it for the first one, and then I'll work on the second one. So thank you very much for watching. Have a nice day.